Let's talk about something that may seem a little bit abstract, but as an IS auditor, you need to know that it exists, and you need to be familiar with the lingo. Networking is such a huge, vast, broad topic that it's very easy to overlook certain things. There is a standardized model of the networking process that was created some time ago by the International Standards Organization, the ISO, and it is called the OSI, or Open System Interconnect Model. The reason why you as an IS auditor need to know it is when you're trying to be thorough, you'll want to look at every stage in the networking process, and this model will help you focus on that. And in fact, you'll hear network engineers talk about, I think it's a layer 3 problem, I think it's a layer 2 problem. Well, we're now going to know what those layers are. So the OSI model came about because the ISO, they were looking at networking products. And back once upon a time, all networking products were proprietary. You had to buy a specific vendor's hardware and software, and nothing worked together. And the ISO said, well, we're a standards body. Why don't we figure out what they all have in common? Let's come up with a common model so that if you're a hardware vendor, you just focus kind of on one stage in networking and make sure that your part works with the other layers. So they decided that networking really boils down to 7 steps. And they laid them out, starting with step 7 or layer 7 at the top, down to layer 1 at the bottom. You may need to know this in general for the CISA exam. At the very, very top is the application layer, layer 7. Now, what this is a user opens a browser or an email client, or they want to send a print job, or they want to connect to a file share. They want to do something on the network, and there's an application that wants to get on the network. The application layer is kind of like a customer service counter where that application can ask the operating system for network services. And the application will speak some kind of language in order to talk to the network. And so here's where these layer 7 protocols come into play. HTTP, HTTPS, FTP, SMB, Telnet, DNS, DHCP, SSH, FTPS, NFS, CIFS. So all of these sort of languages to talk to the network. Cisco often refers to the application layer as a user interface because the user is so often allowed to interact at this level as well. The next layer down, layer 6, is the presentation layer. And the presentation layer's job is basically to let the two sides, like my client and your server, negotiate a common format for the data. Have you ever been to a website and you wanted to watch like a movie trailer, but you got a pop-up saying you need the latest Adobe Flash plugin? Well, that's the presentation layer, basically. One side unable to get the other side to recognize that particular format, and so whoever wrote the application, wrote in something to warn the user, and they even hopefully provide a link so you can just go get the plugin very easily. At the presentation layer, that's where we're going to see levels of encryption, like 40-bit, 128-bit. That's where we're going to see SSL. That's where we're going to see TLS. That's where we're going to see the compression and the codecs, all the media types. So is it a WMV? Is it a MP4? Is it an MP3? Is it a RM? Is it an MOV? Is it a TIFF, a GIF, a JPEG, a bitmap? These are negotiated to make sure both sides can understand them. What is the character set? Unicode, ASCII, EBCDIC. So this is the presentation layer's job, layer 6. Layer 5, session layer, this is where we have the very, very first inkling of connecting to somebody. We haven't connected yet, but we're starting to have the first inkling. Because I open a browser, my browser wants to go to a web server. Now, on my one box, I can have one IP address, but lots of different things going on. And I can have like 5 browsers open. How do I distinguish 5 browsers on one IP address? Well, each browser gets a different port. And all the browsers go to a particular IP address to a web server that's listening on port 80. But my browser, first browser listens or is using port 1000 to identify itself. The next browser uses 1001, the next one uses 1002. How many ports are there? On any one box, 65,536, although we don't use quite all of them. And so this is a 16-bit number, and the operating system temporarily assigns the application, whatever that instance of the application is, a port number, and it's used to identify itself when it makes a connection. So I have an IP address and I have a port number, and that's how that web server, I can have 5 browsers, that's how that web server separates and distinguishes all 5 of my browsers. And this is how I, as a user, can have browsers open, and I'm watching something on here, and this never starts showing up here because each browser has its own little port, and when I close the browser, the port's given back to the OS. So we keep the separate conversations separate. It is true there are other mechanisms, but in today's day and age, ports are the most common mechanism that we use. Now, down to layer 4. This is sort of a pivotal layer. The transport layer hides or abstracts the mechanical details of the network from the upper layers and from the application itself. The transport layer's job is to actually establish the session between me and you. And here is where we have TCP and UDP, and there are other protocols, but these are the 2 main ones. TCP actually has a handshake. How are you? I want to start a session. This is my starting number. What's your starting number? Thank you very much. Thank you very much. Now let's go. And then when we're done, we handshake goodbye. UDP just doesn't bother with a handshake. It just sends data. But this is where we actually have a session. In most cases, if we're using TCP, we not only establish it, we have a handshake, we have starting numbers, but we also, TCP will take a big document. Like you're downloading a whole movie, or you're downloading email, or you're sending a file, or whatever, and you're downloading a whole web page with graphics. It'll take this big thing and chop it up into little pieces, manageable segments, and it'll put a little sequence number on each of them. And part of the handshake is to say, my sequence number is this. What's your sequence number? And that's how we start. And so then this way, all the little pieces are numbered, and then it sends them and waits for an acknowledgement, and if we don't get an acknowledgement, it'll retransmit. So TCP establishes the connection, it manages the connection, it makes sure that all the little pieces get there, it resequences them, puts them back in order, and there are also fields in the TCP header that can basically say, hey, I can take more in one gulp or less, so speed up, slow down, because this is my receive buffer window size. So the transport layer's job is to take data, break it up into manageable chunks, sequence it, start a session, manage that session, finish that session. But we might have all these little pieces, right? We have all these little pieces, but these little pieces don't yet have any sort of addressing on them. They have TCP sequence numbers, but no address. So the third layer 3, network layer, this is where we really get down to the mechanics of networking. Each one of these might have a different TCP sequence number so that the whole thing can be reassembled, but the layer 3 IP is going to put an IP address on, source and destination, and all the little pieces will go. So layer 3's job is to add a logical address, an IP address, and choose the best route. We're going to go this way, we're going to go that way. And on the internet, your route can change from time to time depending if we get congested here, okay, reroute. IP is the main protocol that we use these days at that layer, but it also has a friend called ICMP, and ICMP basically is the Internet Control Messaging Protocol. It's how routers talk to each other of, oh, it expired in transit, I had to throw it away, it's unreachable, or even just the diagnostic echo request, echo reply, which we use in ping. So we do all this sort of addressing and routing at layer 3. And naturally then, on a hardware level, a router's primary function is at layer 3 also, because routers mostly are focused on IP addresses and getting from one network to another. This now brings us down to layer 2, the data link layer, and it actually is broken up into sub-layers, but it's beyond the scope of this class to get too deep in that. But the data link layer's job is to basically put on a physical address. So layer 3 put on a logical address, an IP address. Layer 2 is now going to put on a physical address for that particular network segment. MAC address, frame relay DELSI number, ATM circuit number, telephone number for PPP, X25 identifier, whatever, the physical address for that network segment. And it's going to shape up the data getting ready for transmission on that particular type of media. Then finally down at the very bottom, layer 1, the physical layer, that's where we actually transmit ones and zeros. So it's the speed, the duplex, the clock rate, the voltages, the waveforms, is it baseband, broadband, connectors, cabling, wired, wireless, infrared, fiber optic. We're basically sending ones and zeros. And this is the whole networking process as described by the OSI model. It's good to know that these layers exist so that when you're auditing, you make sure that people have been looking at every single layer, because every single layer here has potential vulnerability. Now you might ask, where does a firewall work? Well, potentially on all layers. But generally when we think of firewall, we tend to think of layer 3 on up. Where does a proxy work? Well, it tends to work up around application layer because it's mostly grabbing content. Where does a switch work? Tends to work down at the data link layer because that's where the MAC addresses are. How do we distinguish between a local area network and a wide area network, LAN and WAN? Those are layer 2 protocols. Where does a repeater work or a network card work? Primarily down at layer 1, physical layer, although we tend to have like a network interface card that is for one specific layer 2 protocol, like an Ethernet NIC, or a wireless access point that is 802.11 that has the wireless access protocol. So anyway, this is the OSI model. Now, TCP/IP, the Department of Defense, DoD, has its own model that actually maps straight to the OSI model. In the TCP/IP DoD model, they basically lumped 5, 6, and 7 together and simply called it application. Transport is transport, although some folks call it host to host. Internet is the name for layer 3, the network layer, and then they lumped the 2 bottom ones down together and called it network interface, or sometimes called network access. So we have these models, and they're very, very useful when you're trying to determine not only why something isn't working, but make sure we have coverage for all aspects of networking. The last thing we're going to talk about is data handling and data classification.